Welcome to today's show. Today I'll be going to teach you on the topic JAMB Chemistry. We're going to cover topic 1, separation of mixtures and purification of what? Chemical substances. So today we'll be covering everything about mixtures. We'll be covering every single thing about mixtures. We'll try to understand mixtures. We'll know why we do mixtures. We'll also check out some methods of separation of mixtures. Then I'll draw some out for you. Also check out the purification of chemical substances. We know what is purification. We know the methods of purification. We know some important jam comparison. We'll look at them. We'll look at them one after the other. Look at one word after the word order. So let's start from what we have for today. So if you can hear me and you can see me, please let me know. Let me know. Let me know. Me and you can see me. Go. You can hear me and you can see me. Alright, so I'm loading the board. So let's go. Alright, so today is going to be a very interesting day because this is the first topic. I'm introducing you to the first topic from the JAMB syllabus. Separation of mixtures and purification of what? Chemical substances. The very first topic we have in our JAMB syllabus. So I hope you're excited to learn this topic with me. I hope you are excited. I hope you're excited. I hope you're excited about today's class. I hope you are about today's what? Is the board clear? Hope the board is clear. Hope the board is very clear. Separation and mixtures. Alright, so first of all, what is a mixture? What is a mixture? What do you understand by a mixture? What is a mixture? What is a what? Mixture. What is a what? Mixture. What is a mixture? You've been hearing of mixture. You know what a mixture. If you know what a mixture, let me know. If you don't know, I will explain what a mixture is. A mixture is a physical combination of two or more substances that are not chemically combined. When we talk about mixture, we are talking about the combination of what? Two or more what? Substances. A mixture is a what? Combination, a physical, a mixture is a what? Physical combination. A mixture is a physical combination of what? Two or more substances. A mixture is a combination of what? Two or more substances that are not chemically what? Combined. That what? Are not chemically combined. So this is what a mixture is. Combination of two or more two or more physical combination. A mixture is a physical combination of two or more substances that are not chemically what combined. Each component one will retain each component will retain its what physical property. Each component will retain its what physical properties, and they can be separated using physical method. They can be separated. They can be separated using physical method. So please take note. Hope you're with your writing materials and hope you're taking note. A mixture is a physical substance. A mixture is a combination of two or more physical what substance that are not chemically what combined together. Each component will take its physical properties and they can be using what physical method. If you understand the definition of this mixture, please in the comment section. Let me in the comment section. And if you us, please let me know. Let me know if you are on this. Is it, can you hear? Is it network is good, and if you can hear me and you can see me properly, you can hear me, you can see me properly, please let me know. So we can what? Alright, let us proceed. So next up, we'll look at different types of mixtures. Types of what? Mixtures. Let's look at types of mixtures. Types of what? Mixtures. Types of what? Mixtures. So when we look at types of mixtures, we have types of what? Mixtures. Types of mixtures. So the first type of mixture we have is what? Homogeneous. We have homogeneous mixtures. Homogeneous example, salt solution. Homogeneous mixture, that's uniform. What? Geneous mixture. In bracket, put uniform, that's this uniform mixture. Example, we have salt solution. These are mixtures that are what? Uniform. Number two, we have what? Heterogeneous mixture. Heterogeneous mixture. Heterogeneous mixture. And you can put in brackets non-uniform. That's for heterogeneous mixtures, non-uniform. Example, sand, water, oil and water. Example, sand and water, oil and water. Sand and water, sand plus, let's say plus water, sand plus water. They are not uniform. We also have oil and water. They are not uniform. Oil, let's use plus water. Please, if you can hear me, you can see me, let me know in the chat. And if you're new to this channel, please make sure you like, share, and subscribe so we can keep pushing out content for you because we want you to succeed in your JAMB. We really want to see you succeed in your JAMB. So these are the types of mixtures we have. We have a homogeneous mixture, which are uniform mixtures. Example, salt solution. We have the heterogeneous mixtures, which are what? Non-uniform. Example, salt plus water plus water. So moving on, we will now know why do we separate mixtures. Now the question is, why do we separate mixtures? Please, if you know the answer to that, let me know in the comment section. Why do we separate mixtures? Please, who knows the answer? Separate what? Why do we separate mixtures? Please let me know. Let me know why we separate mixtures. Why? Is there any specific reason why we separate mixtures? Is there a specific reason to separate mixtures? Just tell us why we mixtures. Why we separate what mixtures? I want to know why we separate mixtures. I really want to know. I'm eager to know why we separate mixtures. Let's go. Let me tell you why we separate mixtures. I'll tell you some mixtures. Please, I'm waiting for you to drop the answer in the comment section. Why do we separate what mixtures? Why do we separate mixtures? Why? Please let me know in the question. I need your. Do you have the answer? Easier CV. I can see you. I can hear you. I can hear you. Okay. I can hear you. So let me know, why do we separate mixtures? 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 Please drop your answer in the chat on the stream. Why do we separate mixtures? Alright, so I'll give you one reason to obtain pure substances. One, to what? Obtain pure substances. I've given you one, I give the next. Give me the next one. Give me the next one. I need to see your answers in the chat. Why do we separate mixtures? Let me see your answers in the chat. Separate mixtures. Why do we separate mixtures? We separate mixtures. Why? I need to know. Tell me why we separate mixtures. Why do we separate the answers? Alright. This to isolate useful components, remove harmful or unwanted impurities for safer use. Beautiful, beautiful. I love that. I love that. You're correct. Impurities. To what? Impurities. To remove impurities. To remove impurities. That is very beautiful. Thank you, Diesel, for letting us know. Another reason is for industrial production. What? For industrial production. For industrial production. Industrial production. Like when you're producing all these petroleum products, you need to separate them so you can produce. Alright, another reason is for what? Laboratory analysis. Analysis. For laboratory analysis. For laboratory analysis. One more in the chat. Let us know why we separate mixtures. Right? Drop it in the chat. Let us know why we mixtures. Why we separate mixtures. Let us know why we separate mixtures. Okay, for water purification. For what? Water what? Purification. For water purification. So these are the reasons why we separate what? Mixtures. Please take notes. Hope you're writing. Please take notes because at the end of the class I'll ask questions. So these are the reasons why we separate what? Mixtures. These are the reasons why we separate mixtures. Now I will go into what? Methods of separation. We have different methods of separation. Different methods of separation. Now I will be touching different methods of what? Separation. Different methods of separation of what? Mixtures. Methods of separation of mixtures. Methods of separation. Methods. Methods of what? Separation. Methods of what? Separation. So number one, the first one we have on our list is what? Give me number one, you should give me number filtration. Filtration is the very first one we have on our list. Filtration. This is very important. We separate solid from liquid. Separation is insoluble solids from what? Liquids. The process of separating insoluble solids from liquids. So now you want to separate an insoluble solid from liquid, right? Through filtration. Let's say this is a funnel. Alright, and this is your beaker. So you want to separate insoluble solids from liquids. You want to separate insoluble solids from liquids. And these are the insoluble solids and the liquid now that is being poured into this thing from a jug. So now you are trying to separate insoluble solids from liquids. You use the what? Method of what? Filtration. You use the what? Method of what? Filtration. You use the what? Method of what? Filtration. So please let me know in the chat another method of what? Separation. Please let me know in the chat. So this can be an example of separation of what? Sand and water. Separation of sand and water. Sand plus what? Water. This can be the separation of sand plus water. So the sand particles will be trapped in the funnel and the water will go inside. That's what one example. Separation. Separation. Now this is called residue. It's called residue. That's the solid left on the paper. That's called a what? Residue. Why this is called what? A filtrate. That's the liquid that passes through it. This is a filtrate. So let's indicate this is a what? Filtrate. Why this is a what? Residue. Please take notes. The residue solid left on the what? Filter paper. While the filtrate is a liquid that passes through the filter paper. So note some JAMB tricks. Note Salt solution cannot be separated by filtration because salt is what? Soluble. Note, please take note. In JAMB, in case they ask you if salt solution can be separated using filtration, it cannot. Salt solution cannot be separated using this what method. Please take note of this. So salt solution cannot be separated using this method in case they ask you in JAMB, because salt is what? Soluble in water. So it cannot be what? Separated using the what? Filtration what? Method. So let's go. What's the next method for separation? Please let me know in the chat the next method for separation. Let me know the next method in the chat. We separate. Daniel Omokwa says, to get pure substances, we separate mixtures to get pure substances. All right, you're correct. Who else? Who else? Who else? Let me know in the chat. Let me know in the chat why we separate mixtures. Let me know why we separate mixtures. Let me know why we separate mixtures. So moving on, number two. If you're done writing this, I can move to number two, right? Number two. Moving on to number two. The second method of separation. Number two. Of evaporation. 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 Evaporating. That means there's heat being applied, right? That means there's heat being applied. Once you hear evaporation, heat being applied to that what you call. Let me say now, let me draw it so you understand better. Let me draw it. When you hear evaporation, what comes to mind? Let's say this is your burner or your gas, right? This is your gas, right? So this is the flame. This is the flame, right? So this is your gas, and there's a flame coming on its heat. There's a flame coming on its heat on your gas. This is your gas. Flame is coming on it. This is it. This is the gas. This is the cylinder. This is the cylinder. This is the cylinder on the burner. And you are asked to separate salt from water, right? And this is the, let's say, the basin or the butter where the salt and the water is. This is water, right? This is water. And these are the salt, dissolved salt in the water. These are the dissolved salt in the water, right? So when you apply the heat, you see that evaporation will occur. Evaporation will occur. This evaporation now, you're what? Removing the water through what? Evaporation. You are removing the water evaporation to be left inside the salt. By the time you finish heating it, the water will evaporate. You'll be left with only salt. So this thing, take note. This is a type 1. Let's say this is a type 1. This is a type 1, right? Let's say a burner. A burner. That's the burner, right? So this is your evaporation dish. So this is the solution, the water plus salt. So this is the burner, the tripod, the evaporation dish, and the water plus salt. So now water is coming out. And what you be left with here now will now be just the salt. When heat is what? Applied. When heat is what? Applied. When heat is what? So this is another method of what? Mixture of solid from solution. So evaporation is what? Simply what? Recovering dissolved solid from solution. Evaporation is simply what? Recovering dissolved solid from what? Solution. From what? Solution. Please take notes. Take notes. The solid is what is living. That's water. Note. The solvent is lost. That's the water is lost. And you are left with the salt. Please, do you understand? If you did, please let me know. Please let me know in the comment. If you're following in the comment section. Verify this. You're doing great, G. Thank you very much. This LTV said chromatography and magnetic separation. That is beautiful. Chromatography, magnetic what? Separation. All right. So let's look at the third one. The third one. So one of our students said in the comment section another method of what? Separation is what? Chromatography and chromatography and let me see what they say. Chromatography and magnetic separation. Correct, correct. Drop more in the chat box. No more methods that you are aware of. Let us know in the chat. Let us know more methods in the chat. Let's know. Let's in the chat. Please let us know more. I love the fact following the class. The fact that the class is active class. The fact that it is an let's look at the third method. The third method is what? Crystallization. 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 So how do I draw this now to explain better for you? So first of all, let me explain what crystallization is. Crystallization is soluble or solid. Example, copper 2 sulfate crystals. When you are what purifying, so I'll draw here. This is what purifying soluble, purifying soluble. When you want to purify soluble solids, with an S, crystallization is purifying soluble solids. Example of purifying soluble copper 2 crystal, copper 2 sulfate crystal. Example, so copper 2 sulfate crystal. But before I proceed to the drawing now, let me tell you the difference between crystallization and evaporation. You know, the both of them sound alike. Purifying solid, soluble solid. The other one was still soluble solid. Evaporation, removing the solvent from the what? Salt. So now this one, evaporation is quick and may destroy crystals. While crystallization is slow, is very slow, as slow cooling pure crystals. So difference is between what? Evaporation and what crystallization. So please take note before I will draw and explain crystallization. The difference between crystallization is that for evaporation it is quick and it is slow. So it is quick. It is quick and what may what destroy crystal. Please take note of this. There are two different things, but if you look at them from the definition, they look alike, but they are different. While crystallization is slow cooling, but gives pure crystal. Slow cooling, slow what? Cooling, but pure crystals. Slow cooling is what? Pure crystallization is very simple. The first step, you have to put it inside. Let me say, put it inside your dish, right? You put the solvent, you put the impure solid, then you stir it to dissolve the solid properly. After you've stirred it, let me draw it so you understand. Let me draw it here. I hope you have written this side, or should I clean this side? So let me draw it. Let me draw it here instead. So the step now for crystallization. The first step now, this is your this thing, right? Then your water is inside already, right? Then you say these particles, these are your solid particles. Then you put this thing to stir it, you stir it, you turn it very well. You turn it, let them mix properly. This is your solvent, don't forget, this is solvent. This is solvent. Yes, that is the solvent. Why this is the impure solid? This is the impure solid. This is solvent, this is impure solid. This is solvent, this water is the solvent. While this one at the end is impure solid. So you use this thing now to stir them, let them mix very well. You stir till they dissolve, you stir till they dissolve. You stir till they what? Dissolve. After that, the next step, you now what? Apply heat. You apply heat. Once they dissolve properly now, you now apply what? Heat. You apply heat. This is this thing. You apply heat. You apply heat. So now you have mixed them properly, the solvent and the impure solid. Now heat. After you've applied it, the thing will now be heating it until you get to a certain temperature. The solution is heated to evaporate to a certain temperature. When you get to a certain temperature, most of this water now will go out. Most of them, that's the solvent. Most of them will go out, right? You are heating it, most of them will go out. The final step is that the solution is not allowed to cool. You will not allow it to cool off because you have mixed it together. You have heated this, what they call the mixture. It's an evaporation of the solvent. Then the next one, you now allow it to cool. Once you allow it to cool, it will form something like this. Crystals. To form crystals. These are crystals. These are crystals. These are what? Crystals. And so you have allowed to cool. Allow what? To cool. So this is the process of what? Crystallization. The three-step process of what? Crystallization. Please, if you got this explanation clear, let me know in the chat box. If you got this explanation clear, please let me know in the chat box so we can move to the next method of what? Separation. We can move to the next method of what? Separation. Now this will give you what? Crystal, which is a pure what? Solid. This is a pure solid. Let me write it down. This will give you a pure solid. This is a pure what? Solid. You remove the impurities. This is not a pure solid. This crystal is a what? Pure solid. This is the process of what? Crystallization. Please, if you understood this explanation, please let me know. Please let me know. Please let me know. Please let me know. If you understood this explanation, please let me know. Let me know. Let me know in the comment section. Drop it in the section. Let me know. Let me know in the section so we can proceed. So we can proceed. Right? The next method. The next method. The fourth. Please hope you are taking notes down. Hope you're taking. Take down those notes. Your JAMB. Please take notes. Please take notes. So the next method. Can you see the board very well? Very well. Let me know. The next method. Hear me. Please let me know if you can hear me. If you can see me and hear me properly, let me know. Let me know. Let me know if you can see me and hear me properly. So we can. Let me know in the chat. Please let me know in the chat if you can see me and hear me very well. So the next method is what? Distillation. 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 Please, can you see the board? Let me know. Please let me know if you can hear it. Distillation. Knows what distillation is. If you know what distillation is in the chat, drop what distillation is in the chat. Please let me know in the chat box. Let me know in the chat box. Distillation. Let what you understand. All right. So this method of separation is very important. You separate liquid from solution, or liquid is large boiling point difference. So this is the process of what? Separating liquid. This is what is the process of what? Separating liquid from a solution. This is the process of separating liquid from a solution. Or you can say or please take note of this, or separating liquid with large boiling point difference. Or the process of what? Separating liquid with what? Large boiling point difference. With large boiling point difference. So this is called what? Distillation. It's called what? Distillation. When you're separating two liquids that have two different boiling points. Yes. So you collect one liquid because the one that has a higher boiling point will still be left down. The one that has the lower boiling point will evaporate first. So you collect that one and the second one will not be left there. So this is what they call distillation. Distillation. So now they have different types of distillation. But before we proceed to the different types of distillation, let me draw what the distillation looks like. Let me draw it. Please take note of this so I can proceed, so I can draw what distillation looks like. How distillation looks like. Let me draw it for you. Please draw it. What distillation looks like. So you can understand. But I don't how it looks like. Distillation, right? So now let's say distillation process. This is now the where did I start from? Okay. Alright, so this thing now here is our what? Thermometer. We have our this. Now this is what see bumping. This is a glass. This is a glass, right? Inside the glass, we have two liquids inside. Two liquids, two liquids, two different liquids, right? Inside the glass. Now, there's another thing again that is like this, like this side again. Another thing that is there, then something to block. You know, these are liquids, so you're trying to trap this. Something to block this thing now, like this. You block it. You block it. So we have gotten what we want now. Now, from this one now, there's an opening here. There's an opening here. An opening here where you collect it. Where you collect what your what trying to separate. This is where you collect them because they have two different boiling points. Let's draw what we are going to collect it in here. Let's draw it. So we're collecting this thing now. We're collecting this here. Right? So these are two liquids that have been mixed together. So here now you apply heat. You apply what heat. Different boiling points. Two different boiling points. This is a shaped flask, a spare shaped, call it a spare shaped flask, a pear shaped flask. This is the flask now. So this is the solution. This is the solution. Two liquids that have mixed together. So now I try to remove them. When you heat it, to a given temperature. Let's say this is our thermometer, right? Then this is our sieve. This is our sieve. This is our thermometer sieve. Then this thing I told that is here again. It's called a sieve head. This is just like air can enter inside. You have trapped it. You have put your thermometer sieve, then you start heating. Once you start heating now, the one that has a lower boiling point will move. Will pass through here and be storing here. To be entering here. It will be storing there, right? It will be storing there. It will be storing there. Now that is what they call the collecting vessel. Collecting what? Vessel. The collecting what? Vessel. This is collecting vessel. It will be storing that liquid here. But note, on this pipe that is running now, there's what they call cold water. Cold water. Cold water now. This way cold water will be entering. Cold water in. Cold water in. That will help it as the cold water is entering, it's cooling this gas. So the gas now change back to water, to the liquid. And the cold water is entering, right? Then there's another place here now on this side. The cold water out. Cold water out. Hope you're understanding what I'm drawing. Cold water out, cold water in. Then there's what they call a lit big condenser, a light big condenser, a light big condenser. This thing is called a light big condenser. This is called a light big condenser. To help us condense, this is the water. This is the water inside the cold water that is coming out. while this one is going in. So this sliding condenser is on both sides. Water is entering from here and coming out from here. It's helping to condense the gas back into a liquid, which will be collected in what? Collecting vessel. So once you heat it from here now, it will come out. The one with the lower boiling point will boil first and evaporate and come out. This is what they call distillation. Please take note, very important, very, very important. And this is called a glass bend. A glass what? Bend. So you are following. This is called a glass what? Bend. So this is the process of what? Distillation. Very important. Very important. They use it in the petroleum industry a lot. So now I'll be giving you the types of distillation. Types of what? Distillation. If you've drawn this, let me know in the chat so I can clean and write the types of distillation. We have simple distillation and we have what? Fractional distillation. Simple distillation and what? Fractional distillation. Types of distillation. Types of what? Distillation. One, we have simple distillation. And two, we have fractional distillation. So these are the two types of distillation we have. So for the simple distillation, this one is used. Take note, this for the simple distillation, this is used when boiling point difference is very what? Large. When the boiling point difference is very large for simple distillation, that's when you are trying to separate something like water from when you are trying to separate water from salt, you can use simple distillation. When the boiling point difference they are very large, you get. Then for this one, fractional distillation. For fractional distillation, you use it when liquids have close boiling point. Close boiling point. Example, ethanol plus water. Crude oil separation. Example, this is for close boiling point. Let me write it down. Close boiling point. Why this one is for large boiling point. Example, when you are removing ethanol plus water. Ethanol, example, let me write the example here so it's not look. Example, ethanol plus water and another example, crude oil separation. So you use fractional distillation when they have close boiling point. Example, when you are separating ethanol from water and when you are separating crude oil separation. While simple distillation, you use it when they have large boiling point for difference. Difference. Please take note. Difference. Please, if you are following me, let me know in the chat box. Let me know in the chat box. So we can move to the next mode of separation. So we can move to the next method of separation. Please, if you are following me, let me know in the chat section. Please. Yes, I am. I am following, sir. Beautiful. Yes, beautiful. I love that. I love that. Following. That is very beautiful. Beautiful. So proceed. Beautiful. Since you're following, we are going to what? Proceed. Beautiful. Let's proceed. The fifth method of separation. The fifth method of separation. The fifth method of separation. Let's look at the fifth method of separation, which is what the separating funnel method. Let's just try separating from them. So this is the fifth method. This is different from filtration. Oh. This is totally different from filtration. This is called the what? Separating funnel method. So Benedicta, one who she say I am following. Figa Danzel says he is following. All right, let's proceed. Let's proceed. An interesting class and an interactive class too. Let's proceed. If you're following, let me know. I love that. Let's go. Let us proceed. So who can tell us what separation funnel method is? Who can tell us what separation funnel method? Let me know. Who can tell us what separation funnel method is? Let me know what separation funnel method is. Who can tell us what separation funnel method is? Who can tell us what separation funnel method is? Separation funnel method. Please, anybody in the chat, let us know. Let us know what separation funnel method is. If you're here in the chat, let us know what separation funnel method is. Let us know what separation funnel method is. I'm waiting for your response. Please let me know, what do you understand separation funnel method? Let me chat. Let me chat. I'm trying to see if everybody is with us. All right, so you can share the link to your friends. Let them join this class. This is the first topic in chemistry. Please let us know. Let us know separation funnel method. So it is used to separate immiscible liquid. Used for what? Separating immiscible liquid. It is what? Used to what? Separate immiscible liquids. It is used to separate what? Immiscible liquid. Example, oil and water. Example, oil plus what? Water. When you want to separate oil and water, you use the what? Separation funnel method. And this is occurring based on their difference in density. Note, please take note. This is because of their what? Based on their difference in density. That is, their density is different, or therefore their weight. Based on their what? Difference in density. Based on their difference in density. So let me draw it for a better understanding. Let me draw it. That's like a space here, so I can draw it. Let me draw it here. The separation funnel method. I want to draw it so you can see, you can have a better understanding. So now this is our, let's say this is our stand. This is our stand. Our stand is like this. This is our stand. This is our stand, right? This is our stand. This is our stand. This is our stand. And this is what is holding it. This is what they, this is our stand. Okay, they are together. Let's see. This is holding it. So this is our stand, right? Stand. And our stand is holding this thing now. Where the two limits are. It's holding where the two liquids are. The two liquids now, they will be passing through here. Right? So things are passing through here, there should be a stop at a stopper. I'll stop it, or I will slow it down. Then this is the water that will come in as. Yes. Then this is where it enter. All right. So this is, let's say, inside here now we have oil and water, right? We put oil and water now. You know that the oil will be on top the water. The oil on top the water because of the difference in density. So this is the water, the oil. This is the oil, while this is the water. So because of their difference in density, now you will just keep this stuff right here. The water will be coming down. You will be watching it with your eye. Once all the water has entered into the conical flask, once all the water has entered, this is water here. Once all the water has entered, you will now stop it. Remember, this is your separating funnel. This is your separating funnel. So when you have put the water in the oil, the density of water, because it has more density, is going to be dropping down, dropping down, dropping down, dropping down. Enter till all the water has entered inside the conical flask, you stop it. So you'll be left with only oil there. So you successfully separated the what? Both of them. You see? So this is called what? Separation funnel method. Separation funnel method used to separate it is used to separate immiscible what? Liquid, example, oil and water. So let's proceed to the next method. Let's proceed to the next method. The next method, if you are done writing, let me know so we can proceed to the next method. Let's proceed. Are you done writing? Are you done writing? So we can proceed to the next method. If you are done writing, let me know so we can proceed to the next method. If you are, please let me know so we are done writing. Say I am done writing. Just type it and I will know so we can proceed to the next method. If you are done writing, write I am done. Next word, method. Very important. Are you done writing? Let me know. Say you can proceed. Let me know in the comment section. Let me know in the comment section if you're following me on writing. Done writing. Let's go. All right. So the next method. The next method of separation is called sublimation. Sublimation. You heard of sublimation? Number 6. Sublimation. This is another method of separation of what? Mixtures. Separating solids where one sublimes. This is process of separating solids where one sublimes. This is the process of separating solids when what? One sublimes. So when one of these can sublime, that this is process of what? Example, now let's use ammonium chloride. Example, ammonium chloride. Who knows another example? Who knows another example? Let's say, okay, iodine. Yes, iodine. So these are examples of sublimation. Iodine, ammonium chloride. So in sublimation, you have solids, two or more. Let's just say two. No, let's not say two or more. Two solids, and one it has the ability to sublime, that's evaporate or disappear. But it's a control, it's a control process. So, processing solid when one sublime. Example, we have the ammonium chloride and we have the what? Iodine. So the sublimation will go to what? Solid. Go to what? Solid. So after solid, it will now go to what? Gas. Gas passing through the liquid state. This is what it means to sublime. Now two solid. One will just move from solid straight to gas. It just disappear and start changing without passing through the liquid state. It's not going to melt. You go from that solid direct to gas. When you have two solids like that, then sublimation process will what? Occur. So let's move on to the next one. The next one we have is called what? Number 7, chromatography. 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 Have you heard of this word before? Yes, this is a method of separation. Chromatography. 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 Do you know the meaning of chromatography? Do you know this is the process of separating colored substances? This is the process of what? Separating colored substances. The process of separating colored substances. The process of separating colored substances. Example, ink pigments. Ink pigments. Now you see you have your red biro, you have your black biro, you have sometimes you have green biro. Those four in one biro, we have green and we have other colors. Now imagine now they mix together. So this is the process chromatography. This one is what you use to separate all of them. Yes, you separate them. I will be able to draw it. Imagine I can draw it. You separate them based on, let me see now, this side now is red, here is yellow, here is what? Blue, green, just like that. Different colors. Let me say here is red, yellow, blue, green. So chromatography now, you're looking at them. You put it into the mixture, right? You put this thing now into the mixture. Let's say this is the mixture now. Where all the colors are, you put it in. The ability for the solid to move up. Now the red will move up, yellow further, blue will move further, green will move further. The ability for them to move, the distance move now. You see that they will be separated. The ink now will be separated. That's what they call chromatography. Distance moved by what? Solid. Distance moved by what? Solid. Distance moved by what? Solid. All right. So let's look at another method. This method is very simple. The next method we're about to look at is very simple. It's called what? The next method is called what? This. So I can The next method is very simple. It's called, let me know in the chat if you understood the previous explanation. Let me know in the chat. This method is very simple. This one is very simple. This method is very simple. Decantation. Decantation. Very simple. Very simple. Simply what? Pouring liquid away from sediment. This is simply what? This is what the process of what? Pouring liquid. The process of pouring liquids away from what? Sediment. Very simple, straight to the point. And the final one we have is what? Number 9, magnetic separation. Magnetic what? Separation. Magnetic separation is also very simple. It's used when one component is what? Magnetic. Now, for this decantation, you can use it when you want to what? Water out of sand when it has settled. Now, for this decantation, right? This is sand, this is water. After it has settled, you can pour it out, pour the water out. You pour it out, you pour it out, you pour it out. You pour water out after 6 minutes. Pour water out of the what? Sand. Afterwards, minutes. That's decantation. Why for magnetic? This is used when one component is what? Magnetic. This is what is used when one component is what? Used when one component is magnetic. Example, iron and sand. Example, iron fillings plus what? Sand. This will be easy to separate. So you bring your magnet, you to attract all the iron fillings. Let's just draw a magnet. You have the sand. To see what? Magnet all the iron fillings. Then you left with only sand. You left with only sand. So next up, let's look at purification of chemical substances. We are done with methods of separation. So we'll be looking at purification of what? Chemical substances. I hope you are taking notes. Let's go. Let's proceed so we can finish today's class. Let me not keep you up late so you can rest for tomorrow. Purification of chemical substances. Purification of what? Chemical substances. Purification of what? Chemical substances. So what is purification? What is purification? What is purification? Please, if you know what purification is, drop it in. Let me read that for everybody. If you know what purification is, drop it in the chat. Please, in this, if you are here with us, you're following purification is. Please let me know in the chat. Let me know. Let me know in the chat what purification is. Let me know what purification is. Let me know what purification what is. Let me know. Let me know. I'm waiting for your answer. What is purification? What is purification? What is purification? Type it in the chat there. Type it in the chat. What is purification? I'm waiting for your answers. You know your answers. Type it, type it. To do that, you have 1 minute to type it. Minutes to it. Please, let's go, let's go. Type is the definition of purification. After this, we'll look at the what method of purification. Then we'll look at the test for purification, and we'll now call it a day. So type it down. Type it down. Methods of purification. After now for purification. Then I'll just give you some important JAMB comparisons. Please let us know. Let in the comment section. Type it. What is purification? What is purification? Are you there with me? Alright, your 1 minute is almost up. Please be fast. Type it. What is purification? If you're there with me, type it. What is purification? Type it in the chat. What is purification? What is purification? Can you see the board clearly? Is it clear? Can you see it clearly? What is purification? Let me know. Let me know. Let me know. Type it. Let me know. What is the question? Purification is the process of removing impurities from a substance to obtain a pure compound. So this is the process of what? Removing impurities from a substance. This is the process of removing impurities from a substance to what? Guys. This is the process of removing impurities from a substance to obtain a pure what? Compound. To obtain a what? Pure compound. Very simple. Very, very simple. So this is the process of removing impurities from a substance to obtain a pure substance. So let's look at some methods of purification. Methods of purification. So we'll look at some methods. So the first method we have is what? Crystallization. The second method we have is called distillation. Who can tell us the third method? Who can tell us the third method? Let us know in the chat. Let us know in the chat. I've mentioned some of them. I explained some of them in the previous example. Let us know in the chat. We have crystallization, distillation, we have recrystallization. And finally, we have chromatography. So these are the methods of what? Purification. So next up, let's look at the what? Test for purification. The test of purification, this is very important in JAMB. The test for purification. Test for what? Purification. If you're done writing this, let me know. If you're done writing this, let me know so I can clean. If you're done writing this, please let me clean. Purification. Let's look at the test of purification. Let's go. Let's go. We are almost done with our class. We are almost done with today's class. Let's go. Let's go. Hope you're enjoying today's class. If you're enjoying today's class, please let me know in the comment section. Yes. This relatively says it is the act or process of making pure by removing unwanted contaminants, foreign elements or pollution. You're very correct, very, very correct. So that's what this relatively says in the chart. It is the act or process of making pure by removing unwanted contaminants, foreign elements or pollution. Figure Denzel say, right on sir, I see you, I hear you. Right on sir, beautiful, beautiful. I love the active engagement from our students all over the world. Beautiful. Let's proceed, let's proceed. We are rounding up the class. So test for purification. We have test for purification, test for purification, test for purification. Test for purification. One, we have melting point, melting point, melting point. Under the test for purification, we have what? Melting point. For this melting point now, pure solids, please take note, have sharp melting point. Impure melt over a range. Take note, that melting point, pure solids, they have what? Sharp melting point. Once it's pure, the melting point is sharp. But for impure solids, for impure solids, for impure solids, let me use arrow since I need arrow for the first one. For pure solids, they have sharp melting points. While for impure solids, they melt over a range. Melt over a what? Range. So this is how you identify which one is a pure solid and an impure solid. From their melting points, that's how you understand if it's pure. For the next one is the boiling point. This is the test for purification. When you want to check if what you separated is pure or not, you check the melting point. Is it melting very fast? If it's melting very fast, then it is a pure solid. But if it's not melting fast, it's melting taking time, it's an impure solid. Next is the what? Boiling point. Boiling point. Boiling point. Boiling point. Boiling point. Who is that now?
Hey, Kim, I want to turn off the gym.
Okay, I'm coming. Just give me 3 minutes. Let me round up. Boiling point. Boiling point. Boiling point. For boiling point, for a pure liquid, a fixed boiling point. For a pure liquid, you have a what? Fixed. For a we have a fixed boiling what? Point. While for an impure liquid, boiling point what? Changes. For an impure liquid, the what? Boiling point changes. For an impure liquid, the boiling point what? Changes. So we are done with the what? Test for purification. When you want to know the boiling point, once the boiling point is fixed, you know it is pure. While if it's changing, then it is impure. We are done for today's. Let's do a recap of what we learned today. A recap. I hope you are writing down. A recap. Let me see if you can remember what we just did. So now, I'll write mixtures here. This is the last thing we'll do for today. We are done for today's class. Then, I'll write mixture, then you tell me the best methods for separation. Let me see if you're following up. Please, I want you to be active in the chat. Please, I want you to be active in the chat. When I write the mixture, you tell me the best method of what? Separation. Anyone you know, just write it down in the chat. So the first one is sand and water. Let me know. Let me know what is the best method for separation. Sand and water. The next one. Let's see sand. We say sand and water, right? Sand and water. See salt and water. Let's see salt and water. What is the best method? Salt plus water. Let me know. Let me know. Sand and water. What is the best method? If you can remember what I just explained now, let me know in the chat. As I'm writing, be giving me the answers. Let's know. Ethanol and water. Ethanol and water. Ethanol plus water. Let me know. Let me know. Let me know. Ethanol plus water. Ethanol plus what? Water. Oil plus. Following this class, you should be able to answer at least one or two, or if not, ammonium chloride plus sand. If you are following this class, you should be able to tell me at least one or two. Number 6, ink pigments. So answers to all this in the chat, please. I need the answers to all this. Tell me the best method. If you have been taking note, tell me the best method of separation a day. Please let me know. I'm waiting for you. Let me know the best methods of separation. Let me know. Salt and water is evaporation, correct. Someone says salt and water is evaporation. Figure Gazelle, correct, correct. Salt and water, correct. Evaporation, correct, correct, correct. Who else? Who else? Let me know. Let me know in the chat. I'm waiting for your answers. Let me know in the chat. Let me know in the chat. That is beautiful. That's beautiful. You are correct. Salt and water is evaporation. Salt and water is evaporation. You are correct. You are very correct. So let me know. Let me know what to answer. To be able to answer the class. Be able to answer this. Someone has said salt and water. Next person or that same person can give us the next example. Person. Eh? Okay, okay, I've lost it. I'm losing like move. Alright, let me know. Ammonium chloride and sand is called sublimation. It's correct. Ammonium chloride is called sublimation. You are correct. Sublimation. Sublimation. You are very correct. Sublimation. Correct, correct, correct. So let me know in the chat. Let me know in the chat. Let me know. Sand and water. Sand and water. What is sand and water? What is ethanol and water? What is oil and water? What is ink pigment? Ink pigment. To know it. This one is just outstanding. If you know it. All right. Correct, correct. I love that. Let me know. Ink pigment. Chromatography. Beautiful, beautiful, beautiful. This boy is killing it. Chromatography. No, this is not ink pigment. Ink pigment, see where ink pigment is chromatography, correct? Chromatography. Wow, this one is that. It's beautiful, beautiful. This here, correct, correct. Beautiful. That means you follow beautiful. I love that. So many ethanol and water Oil and water, ethanol and water. Let's go, let's go, let's go. Separation is used to separate oil and water. Wow, that's beautiful. Separation funnel. Separation funnel. That is lovely. That is lovely. That is lovely. What about ethanol and water? Ethanol and water. Let me know. Ethanol and water. Ethanol and let's go. Let's go. We are running up for today. All right. So let me help you with ethanol and water. Fractional distillation. Fractional distillation. Fractional what? Distillation. Yes. So we are done with the first topic. Topic one under chemistry. JAMB. This is JAMB chemistry. JAMB chemistry. JAMB chemistry. This is JAMB. We are done with the first topic. Separation of mixtures and purification of chemical substances. Hope you enjoyed today's class. If you enjoyed today's class, please don't forget to like, share, and subscribe to our YouTube channel. Also, let other students prepare for JAMB, know what's going on. Where we are having live classes. We will have classes every day on different subjects. Physics, biology, chemistry. We cover different topics following the JAMB syllabus. Please let them know. We also have our WhatsApp group. It's free where you can join and learn trial practice questions. Yes, yes, yes. Hope you enjoyed today's class. Today's class was an amazing class. We have come to the end of today. We have come to the end of today's. We have come of today's class. Beautiful. Hope you enjoyed today's class. Thank you for staying to the end. Thank you for staying to the end. Thank you and God bless you. God bless you too, Tika. God bless you. God bless you. I'm really grateful to have such an amazing student, smart student. You followed up everything. You answered questions. You were paying attention. I'm so grateful to have you in today's section. Thank you to the end of this class. I'll see you same time from 7 tomorrow. We'll learn a new subject and a new topic. That's how we'll keep going. God bless you. Thank you so much. And I hope you enjoyed the class. Thank you so much. See you in our next section. Don't forget to like, share, and subscribe. God bless you. Thank you so much. Thank you. Thank you. Thank you. Thank you so much. Thank you. Thank you. Thank you. Thank you. Thank you. God bless you. Thank you. And God bless you. Staying till today's class. Staying till the end of today's class. Thank you and God bless you for staying till the end of today's class. Thank you so much. Thank you so much. Thank you so much. Thank you so much. All right. I'll see you in our WhatsApp community. I love you all. And this year will be your best jam year ever. This year will be your best jam year ever. I assure you 280 and above. God bless you. Okay, you're still far. Sorry. Benedicta. All right. You can still watch the class. Where are you? Where are you? Where are you? Benedicta, where are you? Okay, where are you? Where are you? Where are you? Let me know. Where are you? Let me know where you are. Let me know where are you? 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 Chat. Let me know in the chat. Tell me where you are. Let me know in the chat. Where are you, Benedicta? Where are you? Where are you? Are you? Let me know in. I want to know where you are in the chat. Please let me know where. Let me know where you are in the chat. Beautiful. So beautiful to have you on here. Where are you? Let me know in the chat where you are. Let me know where you are. You're still far. You. All right. Can let me know where you are. Let me know where you are. All right. Difference between evaporation and crystallization. All right. All right. All right. Okay. All right. That's amazing. All right. That's amazing. I hope you understand. You are understanding. Beautiful. Beautiful. So Benedict, all right. Lord, that's okay. All right. Beautiful. Beautiful. So Benedict, is active. Okay. Okay. Let me plug my fan. Let me plug my fan. I'm coming. All right. So I'm back. Thank you all for staying to the end of this class. Today's class was an interactive section and very amazing. Let me do a shout out. Why Benedicta is learning. Shout out to Diesel TV 7373 for joining us in the class. Shout out to Daniel Omokwa Omoka for joining us in today's class. Shout out to Tega Danzin for joining us in today's class. Shout out to Shout out to Verify This for joining us in today's class. Shout out to Benedicta okay, Wawusi for joining us in today's class. Shout out to everybody that was part of today's class. Shout out to every single person that joined us in today's class. Today's section was really, really amazing. Like it was an amazing session. We learned and we learned a lot today. We learned a lot. Please, for your friends that are not here, please make sure you tell them about this class. They should also go and watch it. Even if they missed it, they should watch it. They should watch the replay. The replay is going to help them in chemistry. Today's class was very, very, very interesting. I can assure you you enjoy it because I took my time to break down everything. I took my time to break it down so that you'll be able to understand everything. Break it down bit by bit, bit by bit. Yes, break it down so you understand. So let me ask again, where are you now? Where are you now? Where are you now? Where are you now? Alright. So let me know where you are. If you're not joining us, let me know where you are. 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 If you're not joining today's class, please let me know where you are. Let's know where you are. Let's know where you are. Okay, beautiful, beautiful. Right on, beautiful, beautiful. Please, right on. I'm here with you. Alright, beautiful, beautiful. So let's go, beautiful, 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 beautiful. This is beautiful, beautiful. So she's in the fourth method of separation. Let's go, let's go. That's beautiful. I'm here with you. Right on, right on, right on. That's how we learn. Very good, very good. Beautiful. Alright. I'll still be sharing the link to those on our WhatsApp group so you can also join in. Yes, so you can join in. Yes. Please, you can copy notes. Feel free to copy notes. Feel free. Please, feel free. Free. To take notes. Please, take notes. Take notes. Take notes. Please, feel free to take notes. Feel free to take notes. Feel free to take notes. You are free to take notes. Yes, you are very free to take notes. You are free to take notes. Yes, you are free to take notes. Feel free to take notes. You are free, 100% free to take notes. You are free to take notes as much as you can so you can understand better. To make you understand better, then write down. You are free to take notes. Take everything serious. Take every point, every separation method. Please take every method very serious. Take every separation method serious because it's going to help you a lot. Take it serious. Yes, take it serious. Take notes, take notes. Make sure you take notes. Yes, important. Very, very important. Very important. Please take notes. Okay, you're only seeing my face. Oh, you only see my face. You can rewind. You can rewind. If you cannot see the class, just rewind. Use your hand and rewind. Rewind to the class. Rewind to the class. Just try. Just sketch it. Okay. You can watch rewind. You can rewind. You can rewind to the class. Then, if you can't draw, if you cannot draw, I will send you Pictures of each method of separation on uh, WhatsApp community. Yes, yes, yes. I'll send the pictures of each method on our WhatsApp community. Yeah, so I can add you up immediately. So you can DM me so I can add you up immediately. So drop a message so I can add you up immediately. Drop a message so I can add you up immediately. Yes, yes, yes. You are always welcome. You are always welcome. Beautiful. That's beautiful. So let me know where you are now. Let me know where you are. Let me know where you are. Okay, where you rewind. Alright. Let me show you where you rewind. Okay. Tap on your screen and you will see a red line beside the play/pause button. Then touch it and hold it and slide back to both the left hand side. Or simply double tap on your screen at the left hand side. Tap your screen at the left hand side. Alright, so this is it. We are done for today. So I'm just helping them to be able to navigate through the class. Alright, so that's it. Thank you so much. Thank you. So you can slide, so you check it out, watch it, take notes, draw. That's all you need to know on how to navigate. Thank you so much for staying to the end of the stream. Thank you and see you in our next class tomorrow.